Okay, to solve this question, this is assignment problems, and here we are going to apply the Hungarian method. Hungarian method is one of the best methods of solving an assignment problem. If you want to know much video on my transportation problems which I have solved, you can check other videos I have using my description button. So now, let's solve this question. Now, we have according to the question, the matrix entries below are processing time of each man in hours. So now we have these are the job available, 1 to 5 jobs, and we have 5 men to be assigned this job to. And now we discover that for the first job here, the hours required by the first person to handle this job is 20. So for this second person, it's going to take him 18, and the third person is going to apply 21 hours. So this fourth person will take 17 hours, and this will be 18 hours. So for the first person to process the second job, it's going to take him 15 hours, while this will spend 20 hours. This will spend 23 hours, like that. So till we get to the final one, which the first person will handle this by 25 hours, this will spend 15 hours, this will spend 25 hours, and this will spend 20 hours, this will also spend 20 hours. Now we want to assign this machine to these 5 men. And how do we do that? The first thing we are going to look at now is we let A, let's put it in matrix form, let A be equal to, so this times, which is hours, so we have 20, we have 18, we have 21, we have 17, we have 18, and for the second one we have 15, we have 20, we have 23, we have 18, and the third one we have 18, 12, 25, 21, 16, we have 20, 14, we have 27, we have 23, we have 19, and the last one we have 25, we have 15, we have 25, we have 20, and we have 20. So this is the first thing we are going to do, and after that we are going to take what you call rule operation, or we call it a rule reduction, anyone will use. So that's the next step we are going to take. And in this rule reduction, this is our first rule. This is rule 1, rule 2, rule 3, rule 4, rule 5, and this is column 1, column 2, column 3, column 4, column 5. Now under the rule reduction method, what we are going to do is we look at the element that is the smallest. So here, what is the smallest number or element here is 15. So this one is 15. Here we have 12 as a small one, the smallest one, 12. Here we have 21 is the smallest one, and here we have 17. Here we have 16. So what are the function of these numbers? So what we are going to do now is we try to A equal to, so we subtract the smallest element from each element in the row. So this 15, we subtract it from each element here. That is 20 minus 15, 15 minus 15, 18 minus 15, 20 minus 15, 25 minus 15. And we're going to have this one will be 5, so this one will be 0, this one will be 3, this one will be 5, this one will be when we subtract this, it will be 10. So for the second one, we are subtracting 12 from each element here as well. So by the time we do that, this one will give us 6, this one will give us 8, this one will give us 0, this one will give us 2, and this one will give us 3. So for the third one, we are subtracting 21 from each element here, and this will give us 0, 2, 4, 6, and 4. So the next one is 17. So when we subtract 17, this one will give us 0, this one will give us 1, 4, 6, 3, and the last one here is 16. So when you subtract 16, we are going to have a 2, 2, 2, 2, 0, 3, and 4. So this is our row reduction. So row reduction is done. Then after the row reduction, the next step is to move to the column reduction. So we are done with row reduction. We now move to the column reduction. So column reduction. So under the column reduction, that's the next one, column reduction. So for the column reduction, we find the smallest element as well. So here we have our column. The smallest element here is 0. So from this, the smallest one is also 0. The smallest one is 0 here as well. The smallest element here is 2. So the smallest element here is 3. So we are going to subtract every 0 from all the elements in this column. So we are going to have our A equal to, so when you subtract 0 from this element, we still have the same value as 5, 6, 0, 0, and 2. So it will not change because 0 will not affect it. So if you now try the second one as well, since it's 0, the value will still remain as 0, 8, 2, 1, and 2. So the third one is also 0, so it will not change. You have a 3, 0, 4, 4, and 0. So the next one is 2. So by the time you subtract from this one will remain 3, this one will remain 0, this one will be 4, this one will be 4, and this one will be 3. So this one, the smallest element here is 3. So by the time you subtract, this one will be 7. So this one will be 0, this one will be 1, this one will be 0, this one will be 1. So we are done with the column reduction. So after the column reduction, the next thing is to assign. We want to assign now. We want to assign the assignments. So in assigning the assignments, that is, in assigning this to this and 5 men, which is 1 to 5, we want to assign this job to this 5 men. So in doing that now, that is the next thing we want to do. So if you take a look, let's repeat what is here. So we have in 5, we have in 6, we have 0, 0, 2, we have in 0, we have 8, we have 1, we have 0, 8, 2. I'm sorry, this 2, 1, and 2. So here we have 3, we have 0, we have 4, we have 4, we have 0, we have 3, we have 0, we have 4, we have 4, we have 3, we have a 7, we have a 0, we have 1, we have a 0, we have 1. So now let's assign it. So we are going to assign the law. One of the laws says, the procedure to assign this is, number 1, if we have 1 0 in a row, we are going to assign it. To assign means you put that 0 in a rectangular block like this. So you put it in a square. But when you have more than 1 0, don't assign it yet. So when you are done with the row, you now try the column as well. So what am I trying to say? If you look at this first row, this is row 1. In this row 1, Do we have 1 0 there? Yes, there is a single 0 here. We are going to assign it. So we write it like this. That means we've assigned someone this, which is the first person here. We've assigned the second job to that person. So you go to this second row, and meanwhile, anywhere you assign job to, all the zeros in the column, you got to cancel it. So there's no 0 here. We don't need to cancel anything. So when you move to the second row, we have 3 zeros, so we cannot assign anything here. We jump to the next row. So if you jump to the next row, we have just single 0 here. Because there is single 0 here, you can assign this as this. So any 0 in this column will be cancelled. We cancel this. So let's move to the next one again. This is the next row, and we have one single 0 here, which is this. We assign it. So any 0 here, we got to cancel it. So there is 0 here. So we cancel this. So we come to the last row here. This is row 2. This is row 3. This is row 4. This is row 5. So here there's one single row here, single 0 here. You assign it like this. So any 0 in this column, you cancel it. So now we are done with the row. So first row, second row, third row, fourth row, and fifth row. We don't have anyone. Then the next thing now is to assign the column. So let's look at the column 1. In column 1, do you have any 0? No. We move to column 2. Do you have any 0? No. The 0 there has been assigned. You move to column 3. Do you have any 0? Unassigned? No. We move to column 4. So do you have any 0? Yes, we have one here. So any 0 at this row will be cancelled. So there's no any other 0. So we move to column 5. Do you have any 0 here? No. Now, can we take our optimal value here? Is the question. Let's check. How many rows do we have? We have 5 rows and 5 columns. Now, how many assignments do we have here? We have 1, 2, 3, 4, 5. We discovered that the 5, which is the number of assignments, is equivalent to the number of rows and columns that we have. That is, we have 5 rows and 5 columns. Therefore, we also have 5 assignments here. That means it is balanced. Our optimal solution can be taken from this place. Then we can now take our final answer. Otherwise, we move to the next step. But if you look at this question, since we've been able to assign the 5 men job, we don't need to move further again. But if there's any condition whereby we have only one person left that is not assigned a job to, we move to another step to further our calculation. So for this, we can stop here. Then to do that now, so this assignment is equally seen that for the first person, we assign the second job to this, which is this. We assign this. So I'll just say our first person is assigned the second job. Then the second person is assigned this, which is 1, 2, 3, 4, the fourth one. And the third person is assigned the first job, which is 1. Then the fourth person is assigned the fifth job, V, and the fifth person is assigned the third job, which is 1, 2, 3. So now our total, or the required task, which is the total time now for the processing. So the total time required now, which is minimum 1, the total minimum hours will be equal to, so we now add. So the first person that we assign the second job, so this is it. The value at the initial value is 15 hours plus the second person is going for 4, so which is number 4. This is number 4, so which is this. So we are going to take 14 hours, and the third person is taking number 1, which is this. The third person is taking number 1, which is 21 hours, plus The fourth person is taking number 5. So fourth person is taking number 5, which is this, and it's 20 hours, plus the last person, which is taking number third. This one is taking number 3, so which is 16 hours. So by the time we add everything now, it's going to give us 86 hours. So this is our final answer. Thank you very much. You can also check for the next video when we are unable to assign the job to all the men that are supposed to be assigned job to. So what will be the next step to take? So I'll drop another video on this particular topic. Thanks so much. Subscribe, like and comment. Thanks.